Alrighty, so as you can see, before you watch this video, you want to make sure that you have your Solving Quadratics booklet out, your calculator, and then obviously your brilliant mind. So go ahead and pause it if you need to go grab your calculator or your book or something like that. We are going to be skipping the factoring section in that booklet and moving straight to square roots. Factoring is a little bit more complicated, and I would rather do that with y'all whenever I'm actually in class. So this one's really not that complicated. It's actually just solving an equation by working backwards, which we know how to do. So let's get started. So go ahead and flip to the square roots page in your booklet. You'll notice that this is not actually in your booklet, so just kind of watch the video for now. I'll let you know whenever you'll start seeing the things that are in your book and when you can start writing in there. So what I have here is I have an equation, y equals 2x squared minus 72, and I went ahead and graphed it over there for you. You'll see, just like we've kind of been talking about, this right here being the vertex. You can see it down here at negative 72, right? And then this was stretched vertically by a scale factor of 2. You can't really tell because it looks pretty wide over there in the picture, but that's because my scale is all off. So anyways, we have those transformations from the parent function, but you'll notice that it hasn't been shifted left or right, okay? It's kind of important for later. So this whole booklet is about finding the zeros, right? Finding the roots, the solutions, the x-intercepts, they all mean the same thing. So if I was to write the roots here, I see one right there at negative 6, 0. And I see another over here at positive 6, 0, okay? The important thing to notice about roots is that they always end in what number? 0, right? If it's an x-intercept, it has to be somewhere along the x-axis, meaning that it's going to be negative 2, 0, or negative 3, 0, or positive 2, 0, negative 1, 0. Anything that ends in a 0 is going to be an x-intercept, okay? So what we want to do now is we want to see if we can solve this without the graph, okay? Well, if we just found out that the y is supposed to be 0, let's go ahead and plug that 0 in for the y in our equation, okay? So here's that original equation. If I plug a 0 in for my y right here, and I try to work backwards, okay? I'm going to add 72 to both sides. So 72 equals 2x squared. And I have to divide by 2 on both sides. So 36 equals x squared. Well, we know what squared equals 36, right? We will take the square root. And most of you are going to say that 6 equals x, right? However, there's another answer to that. Because although, yes, 6 times 6 does give you 36, so does negative 6 times negative 6. So we actually get these two separate answers. Well, what do you know? Those are the same as those roots we found on the graph, okay? So like I said before, this is actually a pretty simple way of doing it. You're just working backwards, but it's important to understand that like why you can do this, okay? And again, the big thing is plugging in that 0, okay? We know that if it's a root, it's going to end in this 0 right here. That means we can plug a 0 in for y and then work backwards, okay? That's the kicker. So let's look at another example. This time I didn't draw the graph because I didn't want us to rely on that for finding the zeros. But let's just kind of estimate what it would look like, okay? The parent function is just x squared, but this one has been shifted down 100. Okay, so again, let's just pretend this is counted by tens, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So it's way down here, right? And it's been vertically stretched by scale factor of 4. Well, this scale's so far off, it's going to be hard to tell, but let's just say it looks something like that, right? That doesn't tell us what the exact roots are. We have no clue what this is or any clue what this is, right? We don't know what our scale is. We don't know if that's actually, you know, 2.8 like it looks like here, if it's actually 20.8. We don't know. So we're going to solve it the other way, right? If we know that we're looking for the zeros or the roots or whatever, that means they have to end in 0, okay? Y has to be 0. So I'm going to go ahead and plug a 0 in right here. Well, if I start working backwards, I'm going to add 100. We will see, divide by 4, that x squared equals 25. Well, if I take square root of both sides, I know that x has to equal positive or negative 5. That little symbol I just wrote, plus minus on top of each other, just stands for both the positive and the negative form, but you could just as easily write them separate, x equals 5 and x equals negative 5. Either way, same thing. Okay, so now we know that these points over here that I was pointing at, right here and right here, these are actually positive 5 and negative 5. Again, we couldn't tell that from our graph because we didn't know what our scale was. So really, I'm actually going to erase this because it's kind of oh, I thought I was going to erase it. Here we go, because it's kind of misleading. Okay. Alrighty, so again, we're just working backwards, plugging 0 in for y and then going backwards. So let's practice. This is actually in your booklet, so you can start recording things in your booklet at this point. So if you look at number 1 here, it's already been solved for you a little bit. It says x squared equals 225. All we're trying to do here is find x. So real easy, we take the square root of both sides. X equals positive or negative 15. Bam, that's our answer. Again, if you wanted to write it as a point, it would be 15, 0 and negative 15, 0. Okay, moving on to number 2. This one, again, same thing. We're trying to get x, so I'm going to add 25 to both sides. So 4x squared equals 25. I divide by 4 on both sides. So x squared equals 25 fourths. Well, you may think, I can't take the square root of that, but we sure can. Okay, square root of the top is 5. Square root of the bottom is 2. So we know that our answers are both positive and negative 5/2. Again, there's lots of ways to write this. You'll see that I'm going to switch it up every time. You can write plus minus with the number. You can write them as points with the 0. Or you can just write them as x equals. Okay. Number 3. Again, trying to get x by itself, so I'll subtract 100 for both sides. So x squared equals negative 100. Okay. So I go to take the square root, and can I take the square root of a negative? Is there any number I can multiply times itself? Well, a negative times a negative equals a positive. A positive times a positive equals a positive. There's never going to be a number I can multiply times itself to get that negative. So my answer here, our favorite, no real solutions. Okay? And the cool thing about us already understanding transformations is that we know if we actually tried to graph this, if we just tried to do a little sketch over here, we know this has been shifted up 100, but it's still like the parent function. Okay, so that means it's like this, right? It's a parent function, but it's just up 100. Well, obviously that's no real solutions because it doesn't cross the x-axis. Okay, that's the only time it'll be no real solutions. All right, so let's keep going. Number 4, I'm going to subtract 5, so x squared equals 0. Okay, some of y'all at this point might freak out. If I take the square root, what times what? That's the same number gives me 0. Well, 0. This is the one time when you actually don't have two answers, okay? You only have one, x equals 0, that's it. This is an example of when it would just be at the origin, and that would be the only time it would even touch the x-axis. The rest of these would look something like this, okay? There's two answers because there's a point there and a point there. This would be an example of when there's just one point, okay? All right, these last two are my favorite. Let's see, I should have some little parts. Oh, there. Okay, so for these two, we still want to work backwards. These look a little bit more like vertex form, but we don't want to go through the hassle of trying to convert them to standard first, and I'll kind of explain why here in a second. So let's just start working backwards as is. Again, here's x. Right now it's being blocked, right? It's kind of in the parentheses. It's got some bodyguards around it. So let's go ahead and divide the 4 and get rid of that from both sides. So I've got x plus 2 all squared equals 81, okay? Well, here's where this little heart's going to come into play. If I take this cutesy little heart, oh no, I need it to come to the front. Let's see, bring to front. Perfect, okay. If I take the heart and I cover up my square, and I've got the heart squared equals 81, well, what would the heart have to equal? The heart would have to be 9 or negative 9, right? So whatever is underneath my heart has to be 9 or negative 9, okay? Now, does that mean my answer's 9 or negative 9? I don't know. Let's see. If I move that heart back over here, I see that what the heart was covering up is what's equal to 9 or negative 9. This right here is 9 or negative 9. So I'm going to go ahead and set it equal. X plus 2 is 9, and x plus 2 could also be negative 9. okay? What I'm essentially doing is I'm taking the square root of that whole expression. And the square root of 81 is the 9 and the negative 9. But those are equal to x plus 2 because that's the square root of that. So I subtract 2, so x equals 7. There's one of my solutions. I subtract 2, and x equals negative 11. Those are my two answers, okay? This kind of problem always weirds people out because you don't get like a positive and negative of the same thing. If I look at the top of this page, I get positive 15, negative 15, positive 5 halves, negative 5 halves. But this is the first time that I get two random numbers. That's really not that weird when you think about the graph, right? Sometimes we have them shifted somewhere. For example, we can see right here this one's been shifted to the left 2. That just means it's like this. Well, obviously, its line of symmetry is in the middle. That means this is that negative 11. This is that positive 7. Okay? So let's try it again. All right, I've got 2 times the quantity of x minus 10 squared. Let's go ahead and get rid of that bodyguard, that 2, divide it out. So I've got x minus 10 all squared equals 100. Okay? So that means when I take my square root of both sides, I know the square root of 100 is 10 and negative 10, right? But the square root of this side is just the x minus 10. Okay? So again, if I need to use that heart to explain it again, if I treat that as just one thing, this, oh man, keep having to move it up. So if this heart squared is 100, that means whatever the heart is equal to 10, and it's also equal to negative 10. So again, the heart is x minus 10. So x minus 10 is 10, and x minus 10 is also negative 10. So we're going to have two answers here. Okay? So I add 10 to both sides, and one of my answers is 20. I add 10 to both sides, and one of my answers is 0. Okay? That's a 0. Looks like a 6, but it's a 0. So let's keep trucking. All right, these two are where your calculator is going to really come into play. We're just going to solve them like normal. So I'm going to subtract 80 on both sides. So negative 80 equals negative 2x squared. Divide by negative 2 on both sides. 40 equals x squared. But here's where it's a little bit different. When I go to take the square root, ooh, sorry about my pen there, I'm going to get whatever the square root of 40 is. That's not a perfect square, right? 6 times 6 is 36, but then 7 times 7 is 49. It jumps over it. So our answer here could either be plus or minus the square root of 40. That would be an acceptable answer. Or you would type it in your calculator to get a more, like a decimal approximation, okay? The square root key on your calculator is underneath the same key that you use to square. So you would press shift and then that x squared key. X squared is next to alpha. So you do shift that button and type in 40, and you would get x is equal to positive 6.325, and x is equal to negative 6.325. You'll notice that your calculator does not give you the positive and the negative, so you just have to really try to remember that. Okay? So same thing on the right side. I'm going to subtract 90 from both sides. So negative 3x squared equals negative 90. Divide by negative 3, and luckily that other negative is going to go away. So x squared equals 30. Well, again, that's not a perfect square. So our options are to either leave our answer as just x equals plus or minus whatever the square root of 30 is. That's one way of writing it, just to show that, hey, we can't actually take the square root of it. Or actually work it out in our calculator, and x would equal positive 5.477. Oops, there's a point there. Or negative 5.477. Okay? I will usually specify which one I prefer. If I prefer just for you to leave it as an irrational like this, or for you to actually decimal it out. If you look up at the instructions here, it says round your answer to the thousandths. So that was kind of your clue, is to actually work it out. Alrighty. Number 9, let's kind of get into some word problems here. For a scene in a movie, a sack of money is dropped from the roof of a skyscraper. Okay? So again, if here's my skyscraper, and we drop it down like this, you'll see it kind of looks like a quadratic. Okay? And they give you this equation. H equals negative 16t plus 576. It says, how long will it take the sack to reach the ground? Well, again, the ground is like our x-axis. We're looking for a root again. So if we're talking about the ground, that means the height here has to be 0. So 0 equals negative 16t squared plus 576. So again, I just work backwards like I've been doing this whole time. Subtract 576. Divide by negative 16. And t squared equals, what is it, 36? 36. Okay? So at this point is when I can take my square root. And I remember that t can be either 6 or negative 6. Well, if we're talking about a real problem here, how long will it take? It's not going to take negative 6 seconds. It's just going to take positive 6 seconds. Even though both of those are roots on the graph, we're talking about an actual sack of money being dropped from a building. So we want to go with the positive number as our official answer, even though both would be our answer for just the general quadratic. Okay, a couple more. So a zookeeper is buying fencing to enclose a pen at the zoo. The pen is an isosceles right triangle, and there's already fence on the side that borders the path. So that's this right here. We already have the fence there. Okay. The area will be 4,500 square feet, and they can buy fencing in whole feet only. How many feet of fencing should he buy? Okay, so we're trying to find the outside edges, right? They've given us the area. Well, that's an important clue as to how to start this, okay? I know the area of a triangle is 1/2 base times height. So let's go ahead and plug in what we have. We know the area is 4,500. We can go ahead and just write down 1/2. Base and height. I look over at my triangle, and I know the base and the height have to be these x's because they share the right angle. And I don't know either of them, so it's just x times x. Well, what is x times x? It's x squared. Okay, now all of a sudden I have a quadratic and I can work backwards and solve it. So let's start by getting rid of that 1/2. So 9,000 equals x squared. I go to take my square root, okay? And my answer gives me 94.868. Notice I put that plus or minus again because technically, mathematically, it can be negative 94.868 or positive 94.868. Now we're talking about a fence at the zoo, so obviously we're going to go with the positive one. And I'm going to refer back to this whole feet only thing. I'm actually going to turn this into positive 95 just because we want whole feet. So I now know that this has to be 95 feet and this has to be 95 feet. Well, if we want to know how much fencing he needs, let's add 95, and he needs 190 feet of fencing. Alrighty, 3 more problems. The height of a skydiver jumping out of an airplane is given by this guy. How long will it take me to reach the ground? Very similar to that sack of money falling out. Same thing with the skydiver, right? If we want the ground, that's a height of 0. So 0 equals negative 16t squared plus 3,200. Feel free to pause this at any time, by the way, if you want to work them out on your own and just kind of jump ahead of me and see if we get the right answers. So I'm going to subtract 3,200 from both sides. Divide by negative 16. We get 200. When I go to take the square root, I don't get a perfect answer. My calculator will tell me that. It says to round to the nearest tenth. So the time is either plus or minus 14.1. But again, we're talking about somebody actually, oh, that's a 1. If we're talking about somebody jumping out of a plane, we're not talking about negative, so I'm just going to say 14.1 seconds. Alrighty, almost done. Number 12, we're talking about volume of a circular pond, so it's actually like a cylinder. They go ahead and they give us the formula for volume. Anytime a formula is given to you, I would go ahead and write that out. We want to make sure we use it. So they tell us the volume is 20,000. Pi is always a constant, it's just there. Radius, we don't know, but it says that's what we're going to find. And then height is 4 feet, the depth. Okay, so again, we just want to work backwards to try to figure out what that r is. It's squared, so that's what shows you it's a quadratic. So let's go ahead and divide by the 4. Okay, come over here. That gives me 5,000, 5,000 equals pi r squared. So again, to get rid of the pi, I just divided on both sides. It's going to give us some weird decimal number. Type in as I go. 1591.5. Okay, at this point I can take my square root. Again, my answer is plus or minus, but we're talking about an actual pond, so I'm just going to go with the positive answer, which is 39.9. Alrighty, last one about Queen Bey, Beyonce. Did I say Beyonce? Beyonce. She would like to display her collection of Grammy Awards on the top of her bookcase shown below. Okay, so she wants them up here. What does a Grammy look like? Isn't it like a big, I don't know. I think that's a Grammy. Anyways, she wants to put them up here. Okay, so we want to make sure she has enough area to do that. Sorry, there's a few typos up here, huh? So the collection covers an area of 400 square inches. So that means this rectangle up here has to have an area of 400. Well, for a rectangle, area equals length times width. So I've got 400 equals 5b times b. Where did I get those from? Down here, my dimensions, 5b and b. So really, 400 equals 5b squared. Okay, I'm just going to start working backwards like I've been doing this whole time. Divide by 5. So 80 equals b squared. I take my square roots. So b equals plus or minus, it says round to the nearest tenth, 8.9. Well, again, we're talking about Beyonce's Grammy shelf, so we're not talking about the negative dimensions. That's not even a thing. We don't say that a room is like negative 5 feet long. So we're going to go with Beyonce's shelf needs to be positive 8.9, is it inches? Yeah, inches long. Alrighty. Okay, at this point, you can move on to your homework, which is in Schoology. It's kind of a little puzzle worksheet, so hopefully that makes it a little bit more bearable. Just download it to Notability and do it there. Save on paper a little bit. Should be really quick. There's not that many problems. It is front and back, though, so make sure you scroll all the way down. If y'all have any questions, just save them for tomorrow. I will be back, and we'll be happy to answer them as quickly as we can before we move on to factoring. Hope y'all have a great day.